So the spring force and the displacement relationship we are going to understand here. Okay, so let me take one spring element. And the forces are applied at their ends. Okay, and let us mention here, this is the node 1 and this is the node 2 and this is a spring element. Okay, so the node 1 will mention as I and node 2 will mention as J, and the force generally on the spring element, it will be applied along the axis, means in a linear form the load will be applied. Okay, at both the ends I am applying. So let us say the force which you applied is Fi and at node 2 it is Fj. Okay, and this is the stiffness in the material. So here from the spring law, or you can say the relation between the spring force and the displacement. Okay, so we will have the one graph here, so that for the better understanding of the given condition. Okay, so here we apply the force. So with respect to the force there will be deformation. For example, here you apply the force, so the displacement it will be at node 1, so ui will be the displacement, and similarly here there will be uj will be the displacement. Okay, so when you look at the graph, so here in vertical axis there will be force and horizontally there will be displacement. Okay, so the here the force that will be directly proportional to the displacement. Okay, so first having a linear element, so for the first condition where force which will be directly proportional to displacement, like F is directly proportional to the displacement via the spring constant. Okay, so there will be spring constant, this will be K. So this graph is for the linear element, force that is directly proportional to the displacement. This will be called as an linear element. Now for when for a non-linear, okay, for a non-linear, this graph will be represented for non-linear element, okay, where the force is not directly proportional to the displacement. Okay, so this is the law of spring, you can say. So here where you can say for force F is equal to, that is with the via constant, spring constant K, this is equal to the displacement. Okay, so indirectly where stiffness element K is equal to what? It is force per unit displacement or deformation. Using this equation we can form the F is equal to K into U. Okay, so here always the K, it will be a stiffness matrix and it should be symmetric. Okay, so these are the something relation between force and the displacement for the spring element, or you can say it is for the 1D bar element. Okay, same concept it will be applied for the 1D bar element also. Thank you.